Hey guys, let's discuss new problem from graph, which is called Kahn's algorithm of topological sort. Okay, so here we will be using BFS and BFS or Q we will be using. Okay, and we will be working here with in degrees. So in degrees means number of edges coming inside the vertices, and out degree is number of edges going outside the vertices. So for example, here in degree of 0 is 2, in degree of 4 is 0, 5 is 0, but 2 is 2. Okay, so you would be given adjacency list of this graph, let's say. So this is the graph, and you would be given adjacency list. So now using this list, what you will do, first you find in degree of all the vertices. Okay, so this is 0, 1, 2, 3, 4, 5. What is the in degree of 0? 0. Okay, in degree of 1 it is again 0. Not in degree of 0 is 2, not 0. Okay, so 2 edges are coming inside 0, right? From 4 and from 4 and from 5. So in degree of 0 is 2, in degree of 1 is 2. Okay, and then in degree of 2 is 1, 3 is 1, 4, 0, 5, 0. Okay, now what you will do, whose in degrees are 0, okay, you just put that into the queue. We will create one queue, first in first out. Okay, so first 4's in degree is 0 and 5 in degree is 0. Okay, now take one by one element from queue. So let's come with 4. Okay, so print 4. 4 is the answer, and whoever is associated with 4, all 4's neighbor. Okay, just decrement its in degree, means you are removing 4 from the graph. Okay, so 4, you will see the adjacency list here, 0 and 1. So just make 0 to 1, and this 1's in degree to 1. Okay, initially it was 2, so 2 minus 1, 2 minus 1. Fine. Now this one gone. Now 5 will come. So print 5. 5 is the answer. And what is the degree of 5? 5 is who is connected with 5, 2 and 0. So when you remove 5 from graph, so definitely all the nodes which are connected with this 5 in degree will also reduce by 1, because the node is not there in the graph now. Okay, so 0 and 2. So 0 will become again 0, and this one will become 0. Now check, is there any vertices whose in degree is 0? Yes, 0. So you have added 0 and then 2. Actually you will add it when it will become 0 that time itself. Okay, now it's time for 0. So who's connected with 0? Nobody. So just print this as answer. 2, who's connected with 2? So in degree of 2, if I remove 2, so in degree of 3 will get decremented by 1, so it will become 0. So 3 will come in the answer. 0 already done, and 2 is already done. Now it's time for 3. So when I remove 3, I'll print 3. Okay, and I'll remove I'll negate in degree of 1, so it will become 0. When it becomes 0, you can add that 1 into the queue, right? And then what is the in degree of 1? It is already 0. Who is connected with 1? Nobody. So 1 will be here in the answer. So your answer will be 4, 5, 0, 2, 3, 1. Okay, so that's it. Thank you. And by the way, if you see the code, let's check the code as well, right? So initially you will take one in degree array. Okay, like this one will be in one array, and then using for loop for each vertices you will apply, you will check its neighbor. Okay, and then you are just incrementing its in degree. So basically you are calculating the in degree. Whoever is connected with that graph, you are just incrementing value in that array for that particular vertices. Okay, by +1. Now after calculating this in degree, you have created one queue. Okay, and then you will add all the vertices whose in degree is equal to 0, okay, into the queue. So that is also done. Now you will create one topo array, this one. Okay, and then index will be 0. You start from 0. Now you will run this while condition, because we are doing BFS. Okay, so BFS is breadth first search. You go level by level. Here we are using queue. So you just poll the value from queue. Okay, whatever you have in the queue. Initially we have added 4 and 5 because its in degree was 0. Okay, so then after taking the element, you just check its a neighbor node. Okay, and decrease its in degree. Once you decrease it, check if any neighbor is there whose in degree is 0, just add that into the queue. Okay, and then continue this process for all the vertices, and at the end just return this topo array. That's it. Thank you.